So now we are going to use the method of differentiation to calculate for instantaneous acceleration and instantaneous velocity. So now, our first question, number 1, state that given that x, meaning distance, is mean that 20 meter plus 9 meter per second square times t square, meaning our x distance was what? 20 plus 9 t square, what? Since all these are units, we can move it. At t equals to 1, at time equals to what? 1. We were asked to calculate the instantaneous velocity, Vx. So now, remember that I told you that Vx equals to what? Here, dx over dt. Since here we have distance against time, equals to what? Dx over what? Dt. And I told you that you are going to use this formula, x to the power x equals to what? N minus 1. Remember that I told you wherever you see a constant c equals to what? 0. So now, here it says bx here equals to dx over what? Dt. This means this equation is our x against t, go, is equivalent to now. First, remember, this is a constant. It's a what? Constant. It's a what? Constant place, meaning it's equal to what? To 0. Any constant equals to what? 0. 0 plus. Now remember that you are to multiply this. I say now, anything, for example, x to the power of n equals to n x n minus 1. Meaning, our n here is 2. Our n here equals to what? 2. Meaning, we put it here, we say 2 here, we have 2 times. The whole here we have 9. We say that since 9 is here now, we have 9t. Then we said n minus 2 means alpha is 2, go. We say 2 minus 1. Where have we said that Vx equals here is 0, we can look it. 2 times 9, 18. T, 2 minus 1 is 1. Is our Bx. This is the expression for Bx velocity. So now the value that Vx equals to what? Here we have our T is 1. 18 times 1 equals what? 18 meter per second. Is our Vx. I know that this will be the somehow complicated place. So I'm going to add another rule here. We have n, for example, n1, for example, x power of n. In case of this, you should use something like this: n times n1 x n minus 1. Just that's how we did this in this case now. So now, the next question is question 2. The question says, the velocity of a particle is given by, mean our v equals to what? 10 plus 2t squared. We said the instantaneous acceleration after a second, ax. After what? T equals what? 5 seconds. So this means that we are going to use the same rule here. So AX is dB over dt. Now from here, I say that AX equals to what? dV over what? dt. Meaning AX here. Now, remember again, that any constant is 0 when we are to differentiate, meaning our 10 here is 0. We put 0 plus. Now, this follows the same rule just like in this case. Oh, here we have our n equals to what? 2 again in this equation, the power. So now here we say 2 here as our n times this equation, n1x, meaning 2t, meaning 2 minus 1, just like in this case. Now our ax equals to 0, is gone. 2 times 2, 4t. Now our ax here equals to 4 times 5, t which is 5, equals what? 20 meter Pascal square. Now you see it. So next I want to solve question 3. Now, question 3 here states that the distance x in meter of a particle at time t in second is given by our distance x equals here 2t cubed minus 3t square minus 5t. Find the distance in the fifth seconds, meaning we should find distance x. The question says find the distance. Find what? The distance x in the fifth seconds. Fifth seconds, meaning our t equals to 5 seconds. This means here is our distance code. We are just here, we know we are not going to differentiate, we are just going to substitute t in this equation. Here we have our x distance equals what? 2 here times our t is 5 5 to the power of 3 here minus 3 again here times again 5 to the power of 2 minus again 5 t again times 5. Here we have x equals to 2 times 5 cubed here, 5 cubed, 125 125 minus 3 times 25 minus 5 times 5 here, 25. X equals to what here? 2 times 125. 2 times what? 125 is 250 250 minus here 3 times 25 again 125 again. No. Here we have 3 times 25 is 75 minus what? 25. Here we can see that 250 minus 75 minus what? Minus 25. Here we have our x equals to what? 150 meter. Here is our distance. So the last question here is given. The question said that the question said that given that the distance x is given by 20 plus 5t square here, 5t square. Since all these are assignments. So the instantaneous velocity we can find the instantaneous velocity equal Vx at t was 3 seconds. So again, remember that the velocity Vx equals to dx over dt. Oh, Vx here equals to what? Remember, 20 is constant, it will become 0. 0 here plus here 5 here is like our n1 here go. We will say n times n1 times x go, meaning here our n here is 2 go, n2 times n1 here go 5 t go 2 minus 1, in this case we have Vx equals to what? Here we have 2 times 5, which is equal to 10. 2 minus 1 is t. Vx equals to 10 times 3 time equal. Vx equals to 30 meter per second. So now